Quantum physicists say that the quantum realm is purely probabilistic or random. But how do we define random? And does it truly exist? And how do I know that the next coin toss will yield heads? We could call randomness an effect without a cause, but this would explain having an object flailing around your bedroom for literally no reason. Assuming ghosts don't exist, this logic eventually breaks down. Nonetheless, people who study chaotic events like fluid dynamics and meteorology may sometimes observe complex processes and deem them random. These guys, of course, do know that the weather can be predefined by certain rules. However, it is extremely hard to accurately study these events because of the sheer amount of variables at play. Tossing a coin, for example, is a quite deterministic process. But because of my ignorance of the weight of the coin, the air density around, the force I exert on it, and tons of other factors, I must resort to the next best thing to predict the outcome. Enter probability. Using probability by knowing my first two coin tosses yielded tails, I could guess that the next coin toss would yield heads by knowing that the outcome tends to average out to an equal likelihood of falling on either side. But I can't know for certain because of the lack of knowledge about all the factors in play that the next coin toss will yield, say, a heads. Quantum physics is infamously weird because quanta, plural of quantum, seem to, instead of behaving like traditional particles, act like waves. Imagine this dot as a particle. It occupies a location in space, but when we see a wave originated from this dot, we can see the wave occupies many locations. In fact, it occupies all locations in a determined space differently depending on its distance from the center of the wave. Quantum physics examines each possible location and gives each quantum particle a probability of being there or not. So quantum physicists, instead of studying properties of a particle, actually study how likely it is for a certain particle to have certain properties. This is where the wave interpretation comes from, and why probability is intrinsically related to quantum physics. But how do we know that we simply don't completely understand all the factors in play, just like with the coin toss and meteorology? How do we know that our current interpretation is the actual skeleton and bedrock of quantum physics, rather than just its shadow? If God does play dice with the universe, shouldn't we understand more by seeking the properties of the die rather than asking how likely it is to get any given number? In other words, is the current theory of quantum physics complete?